coming to me. I was given that opportunity, very fortunately, at 16. And it's amazing how it changes you. It gives you that confidence to stand up and talk. And also I did maths and computing, and that is another excellent combination. So I'd like to know where he gets to in the future. I think we need to track him, yes? CEO of something another? So I reckon, well done. I'm very impressed. I also let my students take class as well. Because again, if you get the right student, they talk a different language to me. I'm a bit old-fashioned, really. And I think you communicate far better to your generation than I can. So if I find the right students, I do that as well. But it's because somebody allowed me to.
Sorry?
It's because somebody allowed me to. So I find that very interesting as well. It's something you might consider. I wrote an essay a while ago. I'm one of the new optimists, scientists in the UK, and I said that the younger people would think differently to us, and it's nice to see that evidence coming forward. They're visual learners. They take their information in far differently than we do. The only problem we've got is we have to design the courses. And I've been involved in actually designing about 30 courses with other universities, as well as my own. And that's what my presentation's about. I've been talking about unicorns. You know, these magical creatures, etc. And I don't think they exist. I think what we're looking at is some skills that we need to sort of like bring together. This term of data scientist, I have a major problem with. I mean, looking at you, right, how many of you really know what a data scientist is? Because I've been talking with lots of you, and you all seem to have a different view. Yeah? I mean, if we just look, how many of you are from business schools? Put your hand up. Business schools? We've got more business schools here than I've ever done in any presentation I've ever taken. Anybody from computing? Which is the other. And the thing is, usually I'm talking to statisticians, not even. And we got one. Hey, is it? Yeah? And if you talk to each other and you think, you ask each other, what is a data scientist? You come up with something different. So what are the skills? Well, I'm going to let you catch up with some of these slides later on because I'm sure you're tired. With my slides, there's lots of hot links in them so that you can click and find more info. Because I don't know about you, when you get to this time of night, you stop processing information. And you think, I wonder, I would really like to know a little bit more. Well, in my slides, there's loads and loads of hot links for you to have a look at. But in the various forums I've been to, a data scientist isn't one person, it's a team of people. And most of you here teach. I don't know about you, my students hate working in groups. And my attitude to them, get real. When you go and get a job, you'll be working as part of a team. Get used to it. So, chasing this big data scientist, unicorn, etc. How do we know that the mix of our subjects are right? What do you put in? It's been interesting talking to many of you, is that mix is different. Some courses, some here have said are unique. No, I've seen a few very similar to most courses that I've heard of today. But the one thing we're realizing is that we're dealing with data-driven whatevers. And so, you know, this right mix, the right for the business, you know, what are the questions? And from the scientist side, you know, we're looking for data-driven answers. So how are we using the results from our data analytics also varies depending on our subject area. So the business side, they're looking for evidence to go in one direction. If they're scientists, they're trying to provide information that what they're thinking is right. So how we use data is different as well. So big data goes unicorn hunting. So, oh God, what is a skill set? And that's what I'm trying to get over, is it doesn't matter what software we're teaching. Do we actually recognize the skills that we're looking for? And I've read so much of, you know, what is a data scientist? Will they become less unicorn-like? Well, I'm seeing from Dr. Tong, the earlier you start teaching data analytics, it's not actually as difficult as people think. And the unicorns are not as difficult to find. And part of that is because they access the world differently. So, years ago, here you go, this will give your age away. How many of you use the internet when you're at school? Put your hand up if you use the internet when you're at school. At school. Not many. Okay, if you've got kids now, how many of your kids use the internet? Put your hand up. See? Grandchild does. So can you see the difference? So from unicorns that you think, you know, we can't find them, hey, these skills are coming in at an earlier age. In the UK, it's now in our GCSE curriculum at high school. It's already in our A level. So we're teaching analytics younger and younger because it's a key skill. So, you know, are you recruiting them? And this is another interesting part of what I do, is that I've been out with employers and they're saying to me, Kathy, we cannot find these unicorns. We're running their CV through our systems and they're not there. So I asked them, I said, would you have the qualifications that you are looking for in these young people? I.e., would you employ yourself? Guess what they said? No. They wouldn't even get through to a short list for the jobs that they are advertising. So if the employers don't know what they want, how can the next generation know what skills and qualifications to get? So, boy, we've got a problem, haven't we? The employers don't know what they want. The young people just want really good jobs, which are interesting. Yeah? And we have to design the curriculum to match that. Talk about impossible. Do you realize that you are rarer than a unicorn? Yeah? Because you've got to write the curriculum to create unicorns. And the employers don't even know what a unicorn is. So actually, your jobs are far more difficult than anything that the unicorns are doing. And that's where, you know, it's really nice for people like IBM and SAS with me to help us create unicorns. So, just what is it? There you go back to what is a data scientist? Highly educated experts who operate on the frontier of analytics, where data sets are so large and the data so messy that less skilled analysts are using tools that they can't make sense of. How many of you feel the tools are the barrier? Have you, you know, do many of you teach it? I mean, I do. And it's really interesting, and I have a lot in common with Dr. Tong here, is I think, again, we need to teach the tools at a younger age. I think pull them away from Excel as soon as possible. Let's teach them with the right tools. I describe this. When I was little, I used to love walnuts. and I could never find the walnut cracker. So I used my mum's shoe and chased it round until I broke it. I eventually did. It would have been much quicker if I had nutcrackers. And that's what I feel about data analytics tools. I think we need to teach the young people the right tools for the job. Don't let them use Excel. Excel has its uses, but when you're doing data analytics, it's like chasing that nut around with my mum's shoe. It doesn't work. So I'm really pleased that in the UK, I've managed to get resources for schools, for high schools. And that's what I said, I've got it into the curriculum. They've got the right tools. So, data scientists mystified, I love this one. Think of how much we're expecting one person to know. It's like, you know, when you go for jobs, isn't it? Please can I have somebody who's about 22, 23, with all the experience of a 50-year-old? We've got some really good examples. They are rare. Most people are normal. But that's what we're expecting. Hey, this is what we're supposed to be expecting to put into our curriculum. So, what could you have? And I think most of you can recognize some of the modules there that you're already putting into your courses. And the spectrum is so wide. It's unbelievable. But it also provides us with an opportunity of creating courses which are unique, which are different, which appeals to particular types of jobs if the employers knew what those jobs were. But there's lots. And in fact, within the programs that I've created, I have all those modules across various programs, but not in a single course. So where do you start? I think of it as very much the colours of the big data curriculum, because it's getting that mix right. But one of the things that you will notice, and I hear a few of you already saying this to me, is there specific subjects that you have to include. But how you include them can vary. So from data analytics, statistics needs to be there, some systems analysis, because if you can't understand the system that you're operating on, whether it's a business system, whether it's a computer system, well, it's got to be the computer system because the data got to reside somewhere. Systems analysis is quite important. Now, to some of you who, I've got at least a few computer people, I also do databases. And I find entity relationship diagrams really useful to teach because it enables students to see how data tables fit together. And that can be quite important because nowadays we're not dealing with data from one source, we're talking about integrated systems where data is stored across a variety of computers, or in the cloud, as they say nowadays. You're bringing it in from here and here and here, and then joining it all together. Actually, working out how you join it together is quite complex, and a little bit of systems analysis really helps. Data analytics tools, essential. You know, you need to learn how to drive the software the industry is using. I know that a few were a bit worried that I lead SAS, but it doesn't matter what the tool is, you need the right tool for the job. I like SAS for when I've got big data sets which I can clean up, I can sort out. If I was coming from a business process perspective, I would switch to Cognos, and that's what you were doing. And this is what we were talking about last night. Use the right tool for the job. So whatever you teach, think of not just a tool, but what skills is coming out of it as well, because that's important. Data analysis. Again, understanding data is essential. It's great fun with students when you sort of like say, what information can you find from this data? And you let them lead, instead of just trying to teach them everything. Let them think. The business environment. Oh, the number of stats courses I've seen that forget to teach anything about business. How can you understand data without understanding the context? So I think that's essential. So you can see that as you create your course, and you're probably looking through this and thinking, actually, I've got a bit in there and I've got a bit in there. Oh, I haven't got anything in there. It's to enable you to start thinking about how do you put the various subjects and skills together. And as I said, I had a look at a lot of courses. And you can see now where various subjects fit in. So from statistics, you can teach a bit of that in data analytics. Business intelligence, you need to put the context in, put the business side. If I pop down to this, actual studies, which is now in my new maths program, it could be, again, in context, business environment. But you can see how I've started to look at how various courses around the world are being put together and saying, hey, look at the colours. See if you can work out how you could improve yours so that students got the skills the employers are looking for. I'm going to whiz through these. You've got access to the slides later. So where did you start? Wherever on that wheel. But have a think. Discover the context. The data is really important. And data analytics? I don't know how many courses I've looked at. Data analytics equals maths. I think I'll have it as an equation for them. But it's what we're really talking about is analysing data. I wish we could get some consensus in the terms that we're using. So, discovering what's missing. Stakeholder analysis. Someone, somewhere will own that data. And you need to access it. It also brings in sort of like the governance side of it. But where do you start in a large organisation? I mean, somewhere somebody thinks that the fairy comes along and delivers you the data. And it's all nice and clean, and it's in a single source and ready to go. Get real, it's not like that. So if we give our students data like that, that's how they'll expect it when they go out in the real world. No. You need to understand a little bit about stakeholder analysis, realise somebody owns it. Accessing the data. I'm a database person as well. Permissions, views, etc. It can be difficult getting permission. I must admit with my students, I like open data, and I let them have a play with that to start with, because they can go and search for it, and it's amazing what's out there. But most of it tends to be little, small data. But you can actually start putting data sets together. And again, it's the information you can get from merging those various data sets into an analytics set, which is fascinating. And the young people, the students, seem to be excellent at that. What do I do? One of my students actually did a project, and he thought that the worst performing students in the UK are West Indian. That was true about a decade ago. It's not anymore. So he said to me, can I do a project that enables me to look at the ethnicity of students against their performance at GCSE and A-level? The data's available, by region in the United Kingdom. So he looked at his own area, Birmingham. He was shocked. What he discovered, West Indian students are not at the bottom anymore. In fact, they were third from the top. Guess who were the bottom? White, working class English. Now, doesn't that sound similar to somewhere else I know? But I would not have put those data sets together, what he did. But because young people have inquiring minds, he did. And I found that really interesting. So it's not just giving them a data set. It's when you combine data sets which are interesting. Context. And then what information needs to be extracted. The number of managers that I know say, can you just produce some descriptive statistics for me? And you're sort of like, yeah, that's no problem. What do you want to do with it, though? And I'm one of those who, I've never really grown up. I still ask the why questions. And they suddenly say, well, I want to find out, oh, no, I don't. And then you talk to them. I'm a requirements engineer as well. And you talk through what information they're trying to find. And you come up with a different answer. And I think that's another thing that we need to teach our students, is that they need that little bit of stats behind them to understand about the difference between descriptive statistics and analytics and finding new information. There's a bog standard stuff that you put on your dashboard, but the other side is, what else can we find? Now, I think William's age, you look at this in a better way than my generation who sit and look through books. The way you think is different. So I think what you find and the way you think, what information is needed, you look very differently. I found this with my students, and I think you have as well. So take that one into account. So data analysis, looking at data. Data in the real world is never clean. It's always messy, and you need to sort it out. There's always bits missing, etc. So whatever tool you're using, you know, does it actually need clean data? Or what goes wrong when it's missing? And why? Why does missing data? Why is it important? You need to have a look at that. So what other subjects are in there? As I said, the stats side, the systems analysis, which I've mentioned, and the tools. Whilst I led SAS, as many of you are now realizing, I actually use all of them. Because somewhere in their life, they might use all of them. I always think of it like driving cars. You know, when you pass your driving test, you start off with your little car and build up to the bigger ones. Yeah? But the thing is that if you, I've got to watch American now, with ours it's a manual car. What do you call it? Stick shift, right. If you pass your license on one, can you drive an automatic? Whilst I don't like teaching R is like driving that gear shift, yeah? I have to really think about it. When I'm using something which is a high-tech tool, it's like driving an automatic. The most important thing is learn to drive. So, here's some examples of my courses. I thought you'd like to see some of the mixes I've done. This is the MSc Business Computing one, where you can see it's computing with some data analytics put in there. What I've done is when you can, if you're probably like me by now, it's the end of the day, I've color-coded them to match my color wheel. So you can see where the various subjects are colored, and you can see I've got mainly computing. My MSc Business Intelligence, you can see, is more varied, and it's more cross-discipline. And you can just see by the colors. If I go back, see, that one's more blue, more computing. Next one, mixed, more interdiscipline. As I said, you can look at these in detail when they go up. But I made this so small that you couldn't read it except to read it later, because by now you're boring. But what this is I started looking at some jobs for you, just to say there's so many out there. But the salaries ranged in the UK in pounds sterling from, what's this lowest there, about 32,000 up to 50,000. What I'm finding with my students, my really good ones, the ones like William, are walking into jobs 40 to 50,000 a year. That's pounds. That's their first job. The more certificates they get, it seems that computer programs are used, and so they do all the certifications they can because that makes them stand out. But the problem I have with my course, although it's quite small compared to some of yours, is that they're being made offers before they finish their course. And that's a big problem for me because I need them to complete, otherwise the dean's after me. But when they're being offered jobs, what can you say? And I tend to deal with the employers and say, let them finish. They can work for you at the same time. And that's what's happened. US jobs, you can see there's the equivalent. So you can have a look at some of those. The money, for young people, it's an ideal career. I'm so pleased that I entered this combination of maths and computing years ago. The jobs are out there. Cognos, SPSS, again, salaries 25 to 40,000. There's a range of jobs out there. The employers are saying to us that I'd prefer them to come with the skills, but we didn't know they were available. Let's just show them what our students can do. Our students are really good at using LinkedIn, Facebook, etc. And a lot of employers are recruiting using social media. Any questions? Yes? Mm-hmm. MIS means something different to me. Developing the management side of it is not something, the management information systems is not a side that I have in mind. I think that again is very specialist. But if you want to understand MIS, then really it helps to have a little bit of database and business. And that's what I'm trying to get with my colours, is to say that if you take a couple of the colours, you could create an MIS course. If you've got all of them, then it's more of the skills required to create young unicorns. Yes. Any other questions? Did you have a question?
I was just curious about sort of where machine learning comes in and your colors.
It can fit in data analytics if you look at the details. I tend to put it in there because it's something to do with the data where you cross it with the tools, because you don't do data mining without the tools, so you can put it in either in the tools. I tend to put it in data analytics because usually there's some maths behind it. So in either, depending on which level you're teaching at. Any other questions? I'm around like everybody else. Okay. I'm sure everyone needs a break now. Thank you very much.